Let us see about dual gate MOSFET, point contact diode, pin diode and avalanche diode. First we can see about dual gate MOSFET. In the case of dual gate MOSFET, the name says that there are two gate terminals are used, and the second gate terminal is used to control and reduce the feedback capacitance between the input as well as the output, and thus the amplifiers becomes more stable, and this mostly used in high frequency RF amplifier application. And the advantage of normal FET is high capacity, so that it cannot be used at higher frequencies. Well, we are seeing this is the symbol of dual gate MOSFET. This is the N channel and this is the P channel, that is dual gate D MOSFET and dual gate N MOSFET. While we are going for this construction, here the dual gate MOSFET is manufactured using silicon on insulated method, and here the silicon channel is grown over silicon oxide layer, and it is like two FETs connected in series, and here the highly doped N middle block acts as the drain for the first FET and source for the second FET, and the gate oxide between gate and the channel is the dielectric layer, and the metal used for gate is conductor, and the channel is also the conductor. So all these three layers together form the capacitor. So it is like two capacitors connected in series. The total capacitance connected in series is lesser than the individual capacitance. Two gates are used to reduce the feedback capacitance at high frequency, and the voltages at both the gates controls the flow of current in the channel. Now we can see the working of dual MOSFET. In the above diagram, here there are two gates and two FETs, and they are top gate, bottom gate, and top FETed and bottom FET. In the top gate voltage is applied and kept constant, and the bottom FET is analyzed. It is found that when the applied voltage is above 3 volt, that is the threshold voltage to the top volt, it remains in the saturation region. Now we can see about point contact diode. Here this is the point contact, that is this is the basic structure of point contact diode. Here the definition for the point contact diode is formed by touching a metallic wire with an N-type semiconductor to form a small area of contact, and here this forms the small point junction. It is used because such a small point junction possesses a small value of junction capacitance, thus the charge stored at the junction is low, and due to this the switching ability of diode is much better than the conventional diode. And while we are seeing the construction, here it is formed by a contact of N-type semiconductor substrate and the tungsten or bronze wire, that is the cadvisor, and the semiconductor used in the construction of point contact diode can be either a silicon or a germanium, but germanium is used exclusively because it possesses the higher carrier capacity. Here the dimensions of the semiconductor substrate is about 1.25 mm square, and its thickness is 0.5 mm thick. One face of the semiconductor substrate is soldered to the metal base by the technique of radio frequency heating. And here while we are seeing this, the working of the point contact diode, this is the construction features of point contact diode. Here while we are seeing this, when the forward bias is applied to point contact diode, the current produced in the device is passed through the cat visor, and here due to this the tungsten wires get heated. Due to this heating, the wires undergo deformation, thus a small gap is deliberated left for the expansion of wire under the large current, and when the wire gets heated, the semiconductor in the contact with the wire also get heated, and due to this it gets melted, and also an atom from visor or passed to semiconductor crystal, and thus the visor acts as a p-type semiconductor. Therefore a p-n junction is formed, that is the p-n junction is formed, but the area of the junction is very small. It can be assumed as a point contact, and also the junction cannot be seen clearly because the size of the junction is very small, and it can be considered as a point junction. The entire device is enclosed in glass or ceramic envelope, and here the supporting substrate, that is the supporting substrate is provided by n-type semiconductor and cadmium to provide the mechanical strength to the device. And here the junction capacitance and the diffused capacitance in this diode is very small, that is about 0.1 to 1 picofarad, and it is because the area of contact between the wire and the n-type substrate is very small. Due to the small area of junction, the density of charge carriers near junction is very low, and thus the low charge stores imparts if the ability to switch fastly. And next one is the pin diode. Here while we are seeing this pin diode, here this is the diode. Pin diode is the diode with a wide undoped intrinsic semiconductor region between a p-type material and the n-type semiconductor. The p-type and the n-type region are typically heavily doped because they are used for ohmic contacts. Here this is the pin diode, and this is the symbolic representation. It consists of a semiconductor diode with three layers, and the usually p and n regions are present, but between them is a layer of intrinsic material, a very low level of doping. This may be either n-type or p-type, and here the thickness of the intrinsic layer is normally very narrow, typically ranging from 10 to 200 microns, and the outer p and n-type regions are then heavily doped. Here the very heavily doped region between the n and p type or wide n region makes an inefficient rectifiers, and zero or reverse bias pin junction, low capacitance so that high resistance to RF signal. And also the pin diode has heavily doped p type and n type region separated by an intrinsic region. When reverse bias, it acts as an almost constant capacitance, and when forward bias, it behaves as a variable resistor. The built-in field structures over the intrinsic region, causing minority carriers to be shifted over by the field over a large volume, and it is often used for large detectors and some high frequency efficiency solar cells. And also here the capacitance between the p and n region decreases because of the increased separation between the p and n region, and this advantages allow the pin diode to have the fast response time. And here while we are going for this operation, here this is the pin diode. When p and n region is unbiased, here that is it is applied, there is a diffusion of electrons and holes across the junction due to the different concentration of atoms in the pin region, and the diffusion of electrons and holes produces a depletion region across the pi and ni junction, and here this is shown in this figure. And here the depletion layer penetrates to a little distance to the n-type and p-type semiconductor region, but to a large distance in the n-type. Such condition, the device has the high value of resistance. And also while we are seeing this, the pin diode is forward bias, and the wide range of the width of the depletion region decreases, and here more carriers are injected into the I region. This reduces the resistance of the I region. The depletion layer is not thick, then the I region becomes folded with the carriers as the suitable bias. Thus, when a pin diode is forward bias, it acts like a variable resistance, and the forward resistance of the intrinsic region decreases with the increasing current. And on the other hand, when the pin diode is reverse bias, the depletion layer becomes thicker as the reverse bias is increased, and the thickness of the depletion layer increases till the I region becomes free of mobility carriers, and the reverse bias at which this happens is known as the shift out voltage. At this stage, the pin acts as a at most constant capacitor. It is shown in this figure. Now we can see about avalanche diode. Here, while we are seeing this avalanche diode, here this is the symbolic representation of this avalanche diode, and here the avalanche diode was designed by the Japanese engineer in the year 1952, and it is a very responsible respective semiconductor detector that used for the photoelectric effect to change light into the electricity. And here the diode uses the avalanche method to provide extra performance as compared to other diodes. Therefore, it is said to be the avalanche diode. These diodes are used to change the signals from optical to electrical, and these diodes can be operated in high reverse bias, and the avalanche diode is similar to the Zener diode. While we are seeing for this construction, here the construction of both the pin diode and the avalanche diode is similar, and this diode includes two heavily doped or two lightly doped regions, and therefore the heavily doped regions are N plus and P plus, whereas lightly doped regions are I and P. And here the diode operation can be done in the depletion layer completely. Therefore, they can be work in the ginger mode in addition to the linear avalanche mode. In this type of operation, the photodiode can be operated at the above breakdown voltage at present, and any other mode is namely sub ginger mode. And also, while we are going for this working principle, the avalanche breakdown occurs mainly once the photodiode is subjected to maximum reverse voltage. This voltage enhances the electric field beyond the depletion layer when instant light penetrates the P plus region, and then it gets absorbed within the extremely respective P region, and therefore the electron hole pairs are generated. And also the charge carriers drift, including this saturation velocity, to the P plus region, whereas a high electric field exists. When the velocity is highest, then charge carriers will collide through other atoms and produces new electron hole pairs. A huge charge carriers pair will result in high photocurrent. Therefore, the signal to noise ratio is given by using this equation, that is power from the photocurrent divided by power, that is a photo detector power plus amplifier noise power. While we are going for this characteristics, the avalanche photodiodes are highly sensitive and high speed based diode, which are used in the internal gate method that works through applying a reverse voltage as compared to the pin type photodiode. And this diode measures low range light, so used in different applications, where high sensitivity is required, like measurement of optical distance and optical communication for long distance. That's all. Thank you.